Now let's look at a very specific type of sequence, a recursive sequence. A recursive sequence is a sequence that uses previous terms to define later terms. Recursive sequences have memory is kind of one way to look at it. If you think about what we did in the previous video where we had to find specific terms, one of the examples asked you to find the 12th term. Well, you didn't need to know terms 11 or 10 or 9 or 8 or any of the ones before it to find the 12th one. With recursive sequences you do. You have to know and use previous terms to get the current or the later terms. So here's a really famous example. It's the Fibonacci sequence. First of all, with recursive sequences they're going to have to give you at least the first term, and often they'll give you maybe the second term or the third term, and then they give you a rule. The rule for the Fibonacci sequence would be something like this: a n equals a n minus 1 plus a n minus 2. Now this is something lots of people have a little bit trouble with, this n minus 1 and n minus 2, but the key to remember here is that you're just talking about the index. In other words, those little subscripts, they just tell you what term you're talking about. They don't tell you the value of the term. They just tell you you're talking about the third term or the fifth term or the 11th term or whatever. So an example here would be that we already have the first and the second term, so what we need next is the third term. So that means I'm plugging in 3 for n. So that would make it a2 plus a1. I'm just plugging in 3 for n. So you see what I mean? This just tells you what term to use. This area, this is just your current term. This is the term that would come right before it. N minus 1 would mean the term right before it, and n minus 2 would mean the two terms before it. So a3 is equal to a2 plus a1. So that means a3 is equal to 1 plus 1, which is 2. So then a4 would be a3 plus a2. So we do a4 equals a3, which is 2, plus a2, which is 1, gives me 3. So then a5 would be the fourth term plus the third term. So that would be the fourth term 3 plus the third term 2, and that would give me 5. And so on. You would just keep following that pattern. Now let's look at another example. This one just gives us the very first term. a1 is 5, so our first term is 5. Then it says ak, you can use k's or n's, those are most commonly used, equals k times a to the k minus 1 minus 2. So let me try to emphasize this again. This is the term you're looking for. This represents the term that came right before it. Minus 1 just means it was one term before it. So a1 is 5. If we're looking for a2, that means k is 2. So 2 times a1 minus 2. So that's 2 times 5 minus 2. 2 times 3 is 6. So that's my second term. My second term is 6. Now to find the third term, now I'm saying k is 3. So 3 times a2 minus 2 equals 3 times 6 minus 2. 3 times 4 is 12. So notice, I'm just plugging in whatever term I am, that gets plugged in here. Third term I plug in 3. Second term I plug in 2. And then what gets plugged in here, or here, same thing, is the term that came just before. It's the one we just found. So let's do one more with this sequence. So a4, k is 4, so we get 4 times a3 minus 2. So that's 4 times, our third term was 12, minus 2. 12 minus 2 is 10, times 4 is 40. So those are recursive sequences. They're sequences that require you to know previous terms in order to determine current or later terms.